Hi viewers, welcome back to class. This video I'll still be teaching bearings, more example on bearings, and the ones I have this period, there are two more examples, a bit complex than the previous one. So the first one, we have the diagram as it is on the board. And the question is, give the bearing of B from A. This is point B. We are asked to give the bearing of B from A. This is point A, viewers. So given the bearing or calculating the bearing of B from A is what we have over here. The bearing of B from A. Looking at the diagram on the board, we can see this angle C, the angle here, 80 degrees. Bearing are written in three figures. 80 degrees. I want us to look at it this way. The angle here, angle C and angle B. This angle C is co-interior angle to B, and the both add up to be 180 degree, which implies that the angle here is going to be 100 degrees. Yeah. The angle here is a co-interior angle to B, which add up to be 180 degrees. So since we have 80 degrees here, angle B, the angle here, the angle that I mapped out here is 100 degrees. And looking at the full turn of angle at a point here being 360 degrees, it means the addition of 100 plus 144 gives 244. So for us to get the co-interior angle here, we're going to subtract 244 from 360 degrees. 244 from 360 degrees. And the result is 116 degrees. I just want to establish something, viewers, that the bearing of A from B, the bearing of point A from B is 244 degrees. That is this 100 plus 144 degrees, because the bearing will start from the north clockwise. So the bearing of point A from B is 244 degrees. So using the opposite bearing method, since the bearing of A from B is already established to be 244 degrees, so the bearing of B from A, which is the opposite bearing, will be to subtract 180 from 244, and the result will be 64 degrees. That is using the opposite bearing. But if we want to do it with the co-interior angle method, the co-interior angle to A is 116 degrees, which add up to be 180. Angle here, we add up to the angle here to give us 180 degrees. So we just have to subtract 116 degrees from 180 degrees and get 64 degrees. So I've been able to establish the answer in two ways now. First of all, I try to establish and give us the bearing of A from B. The bearing of point A from B is 244 degrees. So with that, it's easy to calculate the bearing of B from A because it's an opposite bearing. And when this bearing of A from B, 244, is more than 180 degrees. So what we do is to subtract 180 degrees from 244 degrees and get 64 degrees, which is the bearing of B from A. Using the co-interior angle method, the co-interior angle to A, the co-interior angle to the angle here, which is the bearing of B from A, is 116 degrees, and it must add up to this to be 180. So subtracting 116 from 180, we still have the result of 64 degrees. So the bearing of B from A is 64 degrees. So I move to the second question, viewers. It's becoming easier now. The second question, viewers. AC is a straight line. Give the bearing of B from A. This is point B. This is point A. We are asked to give the bearing of B from A. This is bearing of B from A. Is a straight line. 117 degrees has been given here. Is a straight line, so the angle here is 117 degrees because they is a corresponding angle to this angle. This angle here is a corresponding angle to this angle. So corresponding angles are equal. So as the angle here is 117 degrees, so also the angle here will be 117 degrees. So calculating the bearing of B from A, now this is a co-interior angle. This is a co-interior angle to A. It's a co-interior angle to the bearing of B from A, which is the angle here. And it adds up to be 180 degrees. So what to do now is to subtract 117 from 180 degrees, and that gives us 63 degrees. Therefore, the bearing of B from A is 63 degrees. Thanks, viewer, for watching. Continue to like, watch it, share it, and subscribe to my YouTube channel. Bye.